Python track lead. My day job is a programmer in research and development company. I'm doing deep learning stuff. So if you're doing similar, feel free to connect with me, then we can solve problems together. So, so as Rishika mentioned, I will be doing a little bit of introducing, a little bit lecturing, a lecture on data structure and the inbuilt structure, the built-in data structures in for Python. So in case you are very new to programming and like new to like the whole technology like IT field, we would like to, before we start off the series, we want to introduce you about what is actually data structure. So data structure refers to like the formats to organize data in a memory form. So it stores data with a common pattern. So think of it like if you want to organize your closet, right? So just if data structure helps you to get a better access to analyze and complex, like the complex and large amount of data with the structure. So like if you have like a lot of clothes like me, but like a really tiny space closet, like you want to organize as much, you want to organize like in the categorize everything so that you can access very easy. But in a computer world, it's already done. It's like some kind of system will be built in, so we just have to make use, like fully utilize of it. So there are two types of data structures mainly. So one is like primitive, one is non-primitive. Primitive like data structure is really like source a single value of data, just like a boolean, string, float, integers, and double, so on. Where non-primitive data structure is a complex data structure with like a specific purpose. Usually it's stored as a sequence of data, like array, list, and tuple that we will be talking about today. So so this is a little bit of a chart on the data structure, like the main, how it usually defined. So where primitive is like just straightforward, just like one thing because we represent usually just one value. The non-primitive one actually has two main categories, linear and non-linear. I think we mentioned a little bit about on session one. So these are just like, the non-primitive ones will be the ones that we going throughout the series. So now when I talk about like Boolean strings, like I'll be like, wait, this is not data structure. Like I heard it as a data type. Like, like people can talk about like, oh, data type, even like on the previous like beginner series, we've been mentioning, we've been using the term data type a lot. So it's a little bit of clarification, like what is data structure and what is data type. So data type shares the same property of the data of like for a purpose, where data structure is like a predefined format for like a lot like sequence of structure for accessing and processing data. So you might say they are the same thing. Yes, they are the same thing. But at the end of the day, all like both data type and data structures both access, store, and manage data in their own specific way. So don't get confused like, oh, data structures, data type. They're essential to me. They're essentially the same thing, but I think it's a bit like from my knowledge, it's just a different call. So we have previously we talked about like we have like linear data structure and non-linear data structure for the complex, for the sequence data, right? So each programming language have their own built-in, because it's so commonly used to the point like each programming language have their own predefined one, so that you don't need to like they kind of make it as a default, so you don't need to like rewrite your code and build it up to that format already. So in Python, there are 4 built-in data structures. I hope you heard of it, and if you haven't heard of it, this is fine. That's what we're here for. That's what I'm here for. So learn with me. So we have list, we have set, we have tuple, we have dictionary. these four data structures are very, very, very common on every single programming language. So if you're not too familiar with it, or like you struggle a little bit, like I think this is a good if you know another computer language, this is a good chance for like we can go through it together and understand it like deeper before we move forward to another like another like kind of data structures. So list. If you've done any programming language before, you would definitely use list. List is like the most popular thing out there. So it's an ordered collection of elements. So it stores elements in square brackets. It's very popular and commonly used because it's very flexible. Why? Because first you can store a different data types in the same list. It doesn't need to be like the same data type on on one list, and like you have to move another. And it is also it's also mutable, which means they can be edited after they created. For example, you have it here, like I have a list of movie here. So if you want to take out, if you want to add another wonderful movie inside the list, you feel free to do so. If you want to, like, what Ocean Egg is too old, like it's not as like, I would like, I need to take it out, then you can just pop it. You can just pop the list. You can pop out an item from the list anytime. So set is a hidden, I would say is a hidden gem, because it's not, if you are new to programming language, you don't usually use set as often, because is because they have the exact same, they doing the exact same function as lists, but then like they are unordered instead of order, and they store elements in a curly brackets. Is mutable like list, like you can add elements, but you cannot change it. You cannot change the existing elements. It also allows the different types of data. One thing about set that is the why I said is a hidden gem, because it's very useful when it comes to removing duplicates. So if you have a list of movies, if you have lists of like numbers that you store it in a list, and you wanted to do the quickest way to remove any duplicates to get all the unique values is to use sets. So this is a very useful one, but like just because like it's the same, is to have a very similar function as list, and then list is more flexible, so it's like not often used. But if you want to remove any duplicate item and keep all the unique values, set is the way to go. So underneath, I have an example of like how set it is. So basically, it's the exact same as their list, but with curly brackets and a comma separate between the values. So now we have tuples. So tuples, if you heard of it, like this good. If this is the first time heard of it, we assume everyone is a new learner here. It is an ordered collection of items. It stores element in just a regular bracket. It's immutable. That means the list cannot be modified after it's created, and it cannot be like, it cannot like take out things or like just modify easily. The good thing, like you will ask, like, why do I use tuple then? Like, why, like, if it's not flexible, it's not for me. Guess what? The most common the most common data type of a function, when you use a function, a tuple is always, you see a tuple a lot when you return like the value. Like the return value is always a tuple most of the time, because it's fast. It's because it's inflexible, because it's very inflexible, and illiterate it very fast. It faster than a list, and sometimes a set. So that's why it's really popular when it returns to a function. Sometimes you don't even notice, like when you return a function and they don't know what to call, like the computer doesn't know what to call, they return you a tuple instead. So this, you may ask like why, like so like why? When you're dealing a large amount of data, I'm talking about like gigabytes of data, not like megabytes, like like a large amount of data. Computer time really matters. Everyone talk about, oh, which one is the faster, which rate is the best. When it comes to literation, tuple is the choice because it's a lot faster and it saves a lot of like computing time. So that's just an example. So here is an example how tuple is like. You can see this is the exact same format, the exact same movie, but with a bracket. That's how we can tell. So we have dictionary. So dictionary is very popular. I mean, each element that I just introduced definitely has their own unique way. That's why I'm mentioning it. Dictionary is very good when you want to find something, because it has the index, like it has a defined index. So it's an ordered collection of elements. Its start element is in the curly brackets, and the signature, you may see a lot in the dictionary, is the key value pair. So key is actually a key, like open the door of the key. It's unique, immutable, and sensitive and case sensitive value. So it's an ID. Basically, it's an ID of that list. So the value is basically the value for along with the key with a colon separated, and to just make sure, and then like so basically once you call the key, you call you call the whole value. Now the value can be a single element, or it could be a list. It could be something. It could be like a tuple. It could be a set. It could be anything. So as long as you get the key, you assign the key correctly, just like a database. Anyway, so like you assign the key correctly, and you can call it like any time on any circumstances. So because of that unique function, is very good for mapping elements. So and at the bottom, I do have, and again, I have examples. So I want to categorize the different kinds of movie. I have romance with the action. So like romance, I call it romance and the Titanic. And then like action, I have like Ocean 8 and Wonder Woman 1984. So with the curly brackets, but has like has a pair of elements inside that like for a dictionary, where where set doesn't. So now before we go into the questions, I want to review like Karen, what are you talking about? What mutable? What other? What is this? What? Okay, here is it. Like, so I just want to summarize it to all of you. So that's what that's the four things we talk about. Is like data structure. Mutable determines whether it can be added or not added. It affects the running time of the sequence, because when you add the things, computer, okay, you know what, I'm gonna slow down and then I get it. Like, you need to get it. But when things are not mutable, when things that don't need to touch, it runs really fast. It's just like an express bus versus like a regular bus route if you take buses. Where order is basically has basically the indexing. So if, for example, like a list in the list, like the first element, the second element, you can call it. You can call it because like it has an index. There's a relationship between them. This is number 1A is Apple Titanic is number 1, Ocean 8 is number 2. But when it's not ordered, when it's unordered, there's no relationship. Like Titanic can be at the back and Ocean Lake and be different. So they don't really care. Like let's say it don't really care about it. So that's the feature of like whether the built-in data structure is ordered and unordered. So now I believe this is all I have for the data structure. Did anyone has any questions so far on these four fundamental elements?
So I just saw a question in the chat asking if you could explain mutable again.
Okay, so mutable is mutable, it means like, let me go back to this. Good question, good question. Good to figure out now. So mutable means like let's say if I have like a movie here, right? Ocean 8, like the three movies. Mutable means I can take out Titanic. I don't like Titanic. Like Titanic can be moved now. It can be removed now on my movie list because I've seen it too many times. So I take it out from my list. So you use the pop function. Basically, you use the function. You can use the function to take it out from your list. Where immutable means you cannot take out Titanic, like it's in a set. But you can add, if Titanic has a sequence, Titanic 2, looking it up, you can add on a set, you can add Titanic 2 at the back. So like you can actually add it there, but you cannot change it. You cannot take it out. So that's the difference between mutable and non-mutable. So in a way, mutable is very flexible, means like you can edit the list anytime, changes anytime. But like where immutable, I think tuple is the like, oh, I don't think yeah, tuple is the signature of it. You can't touch anything, nothing. Like you can't edit it because it's so that the computer will run a lot faster because like there's less edit, and then that's not like when you have to choose, like it sometimes takes time, but when you don't have to choose, it runs a lot faster. I hope that answers your questions. I think the best way to try out, what I did, how I confirm it. I actually try it out before I talk to you guys, like actually how to pop it out, pop out an element, edit an element. I think that's the best way to get used to it if like my word doesn't make sense to you, because sometimes when when you do talk verbally, it doesn't make sense. I believe Rishika definitely gonna go to some live coding as well. Hopefully, like it would make sense a little bit more.
There's another question asking if you can go back to the slide that showed the linear and nonlinear data structures. I think sort of like that breakdown.
Oh.
And also, yeah, so that one. And also these slides are available as a PDF on the GitHub repository. The link to that has been shared in the chat, so you can also have your own version of these slides. Let's see. There's another question asking, what is meant by a list being ordered? Can it not be unordered as well?
So a good question. So let me go back to here. So list can be ordered. Order means it has. So for example, if for example, like let me use back the example of Titanic 2. So Titanic. So previously we talked about like this list is mutable. So we take out Titanic 2 because we take out Titanic because like this is too long. Like we watched this movie too many times, trillion times. But then Titanic came out, so we add the Titanic 2 at the list, and then we want to watch movie lists. To you, it doesn't really matter because Ocean 8, Wonder Woman 1984, and Titanic is, I can just watch anytime because we visually see the three items as parallel. They're the same, they're equal. To computer, they're very different. To you, to the computer, this like Ocean 8 is the first, has to be the first. Like for example, if there's like a priority, like Ocean 8 will come up the first. Wonder Woman 1984 come up the second. Titanic 2 came up the third. So this is the order, like AKA indexing. So indexing matters a lot. Sometimes to computers, and especially when you want to find an element in a list, it really matters. Like indexing really matters. So also to computer in like order, the item being ordered and unordered is a lot. Now you can choose to be unordered. You can choose their sequence of element being ordered and unordered by using different functions. For example, you want to use, if you wanted this, if you care about the order. So for example, if you grab, like, you have a list of customer names in your shop, and like you want to know who's the first, like the first like customer is like Mary Smith, like that. Like you care about this, you care Mary Smith is the first, then you use an order data structure. And if you don't care, like, Jane Smith, Mary Smith, like as long as they're in the list, you don't care, you can use an unordered structure. You can use an order, like a data structure, to represent it.
All right, thank you for that. Let's see, I think I see one more question, the difference between a dictionary and maps or hash tables. So, I mean, one thing is that maps and hash tables are something we're going to be getting into sort of later on in our series. And the reason for that is they're a bit more difficult to implement, and they're considered the non-linear data structures. So I would, classify them as like intermediate data structures, whereas dictionaries are sort of a bit more straightforward. Yeah, Karen, if you want to add on anything, but
Yeah, I would agree, because it came up with me that, like, this question came up to me as well when I was prepping this slide. So I definitely agree with what Rishika say. So if you're not too familiar with it, like, if you newbies, definitely use dictionary first. When it comes to hashing, like, it's definitely more, it requires a more system, and like a lot of like it's way more systematic, in the sense that you have to follow a lot of rules. So we will get that like later on in the series. Yes.
cool. I don't see any more questions in the Q&A or the chat. So I think we're good to switch over to the Colab notebook for our live coding session. Thanks, Karen, for going through all of the different data structures for today.
I'm happy to help.
All right, I'm going to share my screen. All right. And let me know if the text is like big enough and viewable. I sort of zoomed in a little bit just to make sure that everyone could see that properly. All right, and yeah, so this notebook can be found as a notebook file. So it's .ipynb in the same GitHub repository as the PDF for the slides. So all you have to do is download that and open it up in Jupyter Notebook or Google Colab. There's also a direct link to the Colab in the slides as well. That was just shared in the chat. Thank you for sharing that, Somya. So that'll take you directly to this Colab notebook. So for today, we're going to be going through the same 4 data structures that we discussed: lists, tuples, dictionaries, and sets. And then I'm just going to do a couple practice interview questions. These sorts of data structures are not as commonly seen in the more advanced technical interview questions. So I only have a couple that I wanted to share, but just to sort of get you to start thinking about how you can use these data structures in your next technical interview. So we're going to start out with lists. So just a quick example. So what we're going to start out by doing is actually declaring a list named list, and then we're going to print it out. Actually, we're going to call it L, just because that's the first letter of list, just to make it simple. So the way we declare that is, first we have the name of our variable, list variable is going to be L, and then using our equal sign, this is the assignment operator. And then just as a reminder, to declare a list, a new list, we use a set of square brackets. So we do that. And then we're going to just put in 3 elements just to make it very simple. Let's do L equals 1, 2, and 3. And so to distinguish separate elements, we just separate them by commas. So it's nice and simple. And then what we can do in the next line is just have L, and we're going to run this cell just to see what it looks like. And we should expect it to have it as 1, 2, 3. All right, so the next thing we're going to do is find out the first value in the list and then print it out. So this is basically a form of indexing, and an index in any data structure is basically the place in the data structure where a certain element exists. So whether it's the first value, second value, third value, whatever it might be. And an important thing to know about programming is that the first value, the index is actually 0. So everything starts at 0, not at 1. So if you want to find the first value in the list, we're going to do our indexing using another set of square brackets, and we're going to do 0. And then if we run that, we should expect it to say 1. So if you were to do L1, then we would expect it to be 2. So that's just kind of how indexing works with lists. Now we're going to do some list operations. So the first thing we're going to do is add an item to the list, and we can do that using the append method. So we already have our list named L declared, so we don't have to, redefine it. And then we can use dot append, and as you can see, it sort of has this handy suggestion of all the different methods that are available with lists. So we have clear, copy, count, extend, etc. We're going to be using the first one here, append, and we're going to append the number 4. Since we already have 1, 2, 3, I'm going to append 4. And then let's run that, and we're going to print out our list. And yeah, as you can see, we have 1, 2, 3, 4. The next thing we're going to do is actually search for an item in the list, and we're going to use the index method for this. So this is similar to indexing where we just had L in the square brackets, but we're actually going to be using the index method for this. And what we do is actually we specify the item itself. So as you recall, when we were doing the indexing up here, we were actually giving it the index itself. So, the 0th index, first index. Here we're giving it the item itself, and then it's going to tell us where in the list it is. So if you do that, you can see that it's 1. And as you remember, the first index is actually the second item in that list. And obviously we can see here that 2 is indeed the second item in our list. The next thing is to use the pop method to remove the last item of a list. And so what we're going to do is l.pop. As you can see here, it's one of the suggested methods. And all we have to do is just do that. And since we're not really specifying anything inside those parentheses, it'll automatically remove the last item. And so it just prints out L for us. And now when we print out the list, now it's 1, 2, 3. If we were to run that again, now you can see that 3 was removed. Yeah, you can keep iterating over that, and eventually your list will become empty. One more method we can use with lists is the count method. And so what we're going to do with this is use it to count the number of items of a certain kind in a list. So what we're going to do is do l.count. It's one of the suggested methods. And here we actually give it the value itself. And so basically it's going to tell us how many instances of the number 2 are there in this list. And we would expect it to be just 1. If we had added, let's say, another 2 here, and now we can see we have 1, 2, 2. If we go back down here and say l.count2, now it should change to 2. So it's very quick, very automatic. And this is why lists are mutable. You're able to go in, remove elements, add elements. You can have multiple of a single element. That's where lists come in pretty handy. The next thing we're going to do is add another, or I guess I already did that, of adding another occurrence of the number 2 to list and then trying the count method again. But now let's actually append maybe a different elements. Let's do l.append 3. And then we're going to say l.count 3. And now we would expect it to be, let's see, I already removed 3. All right, I'm going to add 3 again and then count it again. And as you can see, it automatically changed up to 2. So if we were to actually print out our list, you can see that we have 1, 2, 2, 3, 3, 3. So yeah, and let me actually show you the count of 3, and it should now be 3. So hopefully everyone is understanding that. And okay, I don't see anything in the chat so far. So we're just going to do a couple more operations with lists. The next thing is performing a shallow copy of an existing list. And so a shallow copy is distinct from a deep copy. So there's two different methods to do this. So the first one is what you simply do is say, let's declare another list called L2. And just with the assignment operator, we assign it to L. And then if you print out L, as you can see, it has the exact same values as L2. So that's a shallow copy. What we're going to do next is a deep copy of an existing list. So same way, we have L2 with the assignment operator, but now we're going to be using the copy method. So the copy method is actually performing a deep copy. And so it's two different ways of actually copying the list. And so what the shallow copy does is just basically constructing a new list object and then basically populating it with references from the original one. And so the whatever changes you're making in the original list will appear also in the shallow copy, but with a deep copy, it does not affect any other lists that are being copied from that. So obviously you can imagine different use cases for those. If you want one list to be dependent upon another list, then maybe you might want to have a shallow copy. But if you want to simply copy over the elements of an existing list, but you don't want it to have any sort of attachment to that original list, then a deep copy might be more useful for you. So that's shallow copy and deep copy. And now the last operation for lists is going to be using the sort method. And the sort method is to basically sort the items in a list. And since we have numbers in here, what it's going to do is basically order them from least to greatest. So as you can see, we already have that sort of sorting in there. But what I'm going to do is actually sort of augment our list to make it unsorted, so you can see what it looks like when it's actually sorted. So to our list L, I'm going to append 1, and then let's just print that out. And so now you can see that we have this 1 at the end of our list. So now we're going to sort it just by doing dot sort and then printing it out. And you can see that now the 1 was brought to the front because we sorted it. And this, because we have numerical values, it'll sort it from least to greatest. If you were to have, items in the list that were made up of letters or characters, so like if you had like different types of fruits like apple, orange, lemon, whatever that might be, the way it sorts it is by in alphabetical order. So if you had apple, orange, lemon, it would, if you called sort on that, it would change it to apple, lemon, orange, because L comes before O in the alphabet. So that's kind of just two different scenarios where the sort method works. So whether you have numerical values or alphabetical values inside. So that's everything for lists. I hope everyone is able to follow along. I do see a question about the main difference between shallow and deep copy. So as I mentioned, for shallow copy, you still have sort of a reference to that original list versus a deep copy, you don't have that reference. So a shallow copy is simply copying over all those values, but there's still that sort of attachment of sorts to that original list. A deep copy is copying over the elements, but it's completely separate from that original list. So that's where you kind of have the different use cases. What does the L in list mean? I'm not too sure. I mean, the name of our list that we have sort of declared and that we're working with is, I've just decided to name it L. I am not sure if, yeah, so this L here is the name of our list itself. So I just chose to name it L, but you could name it anything you want, really. And that upon that, whatever the name of your list is, that's where you call your different methods. So dot pen, dot sort, all of that. So let's see, does it sort if you have values? Okay, I believe that's being answered. And then difference between L dot sort and sorted L. So let's see if we can try that. So we do that. It outputs the same exact value no matter what. So as you can see here, as we're typing out the sorted thing, it can take in any iterable. So that means that basically any list that you have, which is an iterable data structure, it will return it in ascending order. So, 1, 2, 3, 4. So if you have 1, 4, 3, 2, 1, it'll be then outputted as 1, 2, 3, 4. So it gives you the same exact output as L.sort or sorted L. It's the exact same thing. I believe with sorted, you have some other parameters you can specify. So here you have key, reverse, all of that. So a key is where you can have a dictionary. So sorted can sort of be applied to data structures beyond just a list, whereas this L.sort is something that's a specific method for our list. So I hope that answers the question. I will move on to tuples now. So for tuples, just as a reminder, these are immutable. So once you've sort of declared them, you can't really, it just the way that you can add and like remove an item is sort of done in a slightly different way. So what we're going to do is declare a tuple using parentheses. So for lists, we use a set of square brackets. Here we use parentheses, and we're going to name our tuple colors. And so inside there, I'm actually going to start using some words. So we're going to have red. We're going to have green. And then we're going to have blue. And then we're just going to print it out, just see what it looks like. And there's our tuple with our 3 elements inside. So now we're going to add an item. And so what we're going to do is do colors equals colors plus. And as you can already see how different of a way this is done as compared to a list, where you can just use a method, do dot append, and it adds it very easily. Here it's done in a much different fashion, where you actually have to use a pretty common thing for programming, where if you want to just update the value for something, basically set it equal to itself, and then you're adding on some sort of value. In this case, I basically just added on the word orange to the end of this tuple. The next thing we want to do is actually access an item in the tuple. Again, this is done in a slightly different way as compared to a list. Tuple methods and the operations you can do with the tuple are, I think, a bit more wordy and sort of seem like a workaround, because you can't very directly do it as much as you can with a list. So what you're going to do is do print colors. And this is basically just going to say that our 0th element, so this in this case would be red. And then I'm going to print out the 0th element, which is colors 0 and that. And so what you would expect is color 0 is red. So we can change that simply to 2 and 2. And so we would expect that to be blue. The next thing we're going to do is update an existing tuple. So this is similar to kind of how we had, having a shallow or a deep copy of a list, or basically creating a new tuple from the existing tuple. So we're going to have colors 2 and colors 3. So colors 2 is going to contain slightly different colors. We're going to have purple, we're going to have pink, and we're going to have brown. And then in colors 3, we're going to say colors 3 is equal to colors plus colors 2. So essentially, they're just taking in all of the values from colors, all the values from colors 2, and combining it into a single tuple, and basically concatenating these two tuples together. So now let's print out colors 3. And as we expected, they basically just took red, green, blue, orange in the front, and then just at the end, just added on purple, pink, brown. So if we were to add on, say, the color black to colors and then run this again, black basically just gets added up here. So you don't really have the same sort of operations as like a very simple copy like you did with the list. This is kind of how you would create a new tuple from an existing tuple. So it's in a similar fashion using the plus sign as you were doing for adding an item to the tuple. So this is the operations that we have. There are more operations than I'm covering in this notebook, because obviously I can't go through all of them, but this is just to compare, the operations that we have for a list versus a tuple. Let me see if there's any questions. Okay, I think we're good to go to, let's see. So why is there a comma in the tuple orange when it is the only element? Is this convention? So I'm guessing you're referring to here. Yeah, so that's typically that's the conventional way to add the element. So even if it's the only element you're adding, you do need that comma to be appended at the end of the single item that you're adding. If you were to add in more elements, you would maintain that same convention of having a comma after that item that you're adding to the tuple. Okay, so now we have dictionaries and sets. So for dictionaries, the way we declare a new dictionary is using square brackets. And so we're going to name our dictionary my dict. And then we're going to say with our curly, sorry, not square brackets, with the curly braces. And so the way we define dictionaries is we have a key and a value. So first we define the key, and then with the colon, we define the value. So that's kind of how we say that this key is associated with this value, is by using a colon in between. And then to have another set of a key value pair, you put a comma in between. And then I'm just putting in some values about myself. So I have occupation, and then I have student, and then I'm going to put country, and then USA. So we have 3 key value pairs. And now let's just print this out to see what it looks like. So it looks exactly like how we sort of defined it here. We have country, name, and occupation. As you can see that it automatically ordered the dictionary in alphabetical order according to the keys. So we have country, name, and occupation. Even though we defined it in a different way, the dictionary automatically ordered it in that way, which is pretty handy. So the next thing we're going to do is access an item from this dictionary that we have just declared. So what you're going to do is print and then type out the name of our dictionary, and then we're going to say name. And so what you would expect is the value that's associated with that key, which is let's see, I forgot a parenthesis right there. All right. So that's how you access an item from a dictionary. So you provide Python the key that's associated with the value, and then it'll return the value to you. Now let's print out, let's access another item. Let's do same with the name of our dictionary. And now we're going to be using a slightly different method called .get. Basically achieves the exact same thing as retrieving an item in the dictionary. But again, we still have to provide it the key that's associated with that value. So that sort of convention is not changing at all. So once we run that, we can see USA. So that's basically another way to access items from the dictionary. So either we can provide directly using sort of this indexing type method, but instead of providing its index, we provide the keys associated value, sorry, the values associated key, or we can use a .get method to again provide it the key. The next thing is to modify an item of the dictionary. So the way we modify it is, again, we're providing it the key. In this case, we're actually going to set it equal to our new value. So now I'm actually updating the associated value for this occupation key. And it's very simple as that. And now, as you can see, this occupation was changed from student to programmer. So that's how easily it's done. The next thing is to add an item to the dictionary. So here we have our dictionary, and we're going to add a new item. So we have to add both the key and the value. So we're going to have state as our key. And then I'm going to set that equal to our value, which is going to be California, because that is where I live. And then we're going to print out our dictionary. And now we have another value added here, another key value pair added here at the end for state and California. And now the last thing to do for a dictionary is to remove an item. And so this is going to be using the .pop method, which is something that is also available if you have a list. So we're going to use mydict.pop. And what we're going to do is, again, provide the key. So as you can see, a lot of operations with dictionaries has to do with providing it the key, and then that's how it's able to do something with the item. So here, what we're going to be doing is completely removing country and USA. So it's not going to remove just USA, it's going to remove that entire pair of key and value. So now let's print this out to see if it actually removed it, and it did. So now we only have name, occupation, and state. So these are the different operations with dictionaries. So we can declare using these curly braces. We can access an item using two different methods. We can modify an item, so basically keeping the same key there but changing the value. We can add an item to the dictionary as well as remove any item from the dictionary. Let's see, so I see a question about where do we find the rules as to when to use commas and other symbols. So that's mostly has to do with syntax. And I think there's definitely, several Python user guides out there and lots of resources out there. I do have some references at the end of this notebook that will take you directly to resources that I use to make these examples. And it's sort of just general conventions that have to be used so you don't face any sort of syntax errors and for you to properly work with your different data structures. So yeah, I hope that answers your question. So I don't see any more questions in the Q&A. So I'll move on to our last section, which is on sets. So sets are something slightly different. I wouldn't say they're as popularly used as like a list or a dictionary, but they still have some really unique methods that other data structures don't have. So the way we declare a new set is using curly braces. So here we have our set called my set, and then using our assignment operator, we're going to declare my set to contain 3 values. Let's say we're going to have 2, 1, and 3. And let's just print this out to see what it looks like. I forgot a comma there. See, syntax is very important. So now we have 1, 2, 3. And the next thing we're going to do is actually find out the set size. And the way we do that is using the len method. And then we just provided our set name, and as expected, the value is 3. So this len is common to other data structures as well. I believe you can use it for lists, and I believe you can use it for tuples. And so it's a pretty common method just in general to find out the size of any data structure that you've already defined. The next thing we're going to do is test for set membership. And so set membership meaning, does that value belong to this list? So what we're going to do is first check for the number 2. And so obviously the 2 is our first value. So we expect it to be, give us the value of true. And so when we're doing testing for set membership, we're actually using the in operator. And the in operator is going to then return you either a true or a false, which is a Boolean value. And so Booleans are basically just, you're testing for something or you're comparing 2 different values. They have lots of applications. And so in this case, we are returning a Boolean value. So what we're going to do is do 2 in my set, and we would expect the value for this to be true. And now we're going to check for 4, and we would expect the value for this to be false. So now we would, let me actually do this in a separate cell so we can see both values. So first 2 in my set is going to be true. 4 in my set will be false. And we can also check for 1, since we know that's definitely in there. We can check for 10. That's going to be false, because as you see here, our my set does not contain 10. The next thing we can do is to have a union of 2 sets. And so a union of 2 sets is basically combining all of the values into a single set from 2 different sets that you've already declared. So first we have to declare a second set, and I'm going to call that set 2. And let's just put in some more values in there. Let's do 6, 8, 7, and 1. And in our union set, the way we declare a union is by doing my set, and then this right here, and then set 2. And now let's print out union set. And as you can see here, it basically concatenated all the values from my set and set 2. So we have 1, 2, 3, 6, 7, 8. And just like it was doing for dictionaries, when we're creating this new set and printing it out, it actually automatically orders it for you. So it's pretty nice that way. The next thing we're checking for is the intersection of two sets. And so the intersection is basically what common values are there between the two sets. So what we're going to do is have this new set called intersection set. And then using our assignment operator, we're going to check for my set. And then using the and sign or the ampersand, and then set 2. And then we're going to print out intersection set. And what we'd expect is a value 1, because that's the only common value to both. So as you can see here, set 2 has 6, 8, 7, 1. And my set had 1, 2, 3. So 1 is the only common value. So that's where the only intersection is occurring between these two sets. And now our last operation is to find the difference. So the difference, the way we do that very simply is with the minus sign. And then let's print out the difference set. And here we see 2 and 3. So as you can see here, we have different operations for sets. So we first declared it, we found out the size of our set, we can test for membership of any items in the set, and then we can do union, intersection, and difference. So that's all for sets. And now our last section is going to be going over some practice interview questions. I have 4 questions here, and they're going to each be using slightly different data structures. So the first one is, what will be the output of the following code? So I've typed it here in normal text and also in the coding block as well. So you have init tuple equals parentheses, and then on the second line, print init tuple dot length. So here we're using our dot length method. Does anyone want to take a guess? You can feel free to put your answer in the chat. And the way we find out the answer is I'm just going to run this piece of code, but I want to see if anyone can guess. Okay, so I'm seeing 0, 0, 0. Okay, all right. And now let's run this and see. And 0 is correct. And the reason is because even though we've declared our tuple init tuple, there's no elements in there. So the length is going to be 0. So great catch. That was kind of a trick question. So the next question is just sort of a simple multiple choice. Which of the following statements given below is or are true? So tuples have structure, lists have an order. Tuples are homogeneous, lists are heterogeneous. Tuples are immutable, whereas lists are mutable, or D, all of them. So does anyone have any answer for this one? Let's see, I see C, I see D. So you can, I should probably make this clear. You can select more than one of these. So A and B can be true, B and C can be true, or all of them. So maybe I should have made that clear. Let's see. So I see A and C, A and C. All right. Yeah, so good catch. So A and C are correct. So tuples and lists, it's not necessary that tuples have to be homogeneous and lists have to be heterogeneous, but it is true that tuples do have the structure of them and lists have order to them. And so there is a really important distinction between something being ordered versus sorted. And then, just probably the most important distinction between tuples and lists is that tuples are immutable, lists are mutable, and because of that, tuples are typically quicker in iterating over them, whether you're going through the different indexes and trying to find out the different values, or you're actually creating them. So in this context, homogeneous and heterogeneous means basically the different types of values, like sort of the data types that you can have inside these data structures. So, whether if you can have a combination of a number and a letter or a string, things like that. So that's what I mean in this context. All right, great job, everyone. So here we have two more questions. So question number 3 is, what will be the output of the following code snippet? So here we have A equals 1, 2, and then 2, 3, 2, and then we're going to print out 1 and 2. So this might be a little, this is a little bit more advanced, but I want to see if anyone can guess what will be the output. I'll let everyone put in a few more guesses, and then we'll see what okay, so I see a ton of answers to 1, and that is correct. The value that we get here is 1. So as you can see here, we're declaring this value A using our assignment operator. And what we're printing out is basically what we're trying to print out here is looking at 1, 2. And so this 1, 2 value using our colon is associated with our, or this key here is associated with our value 1. So that's why we get the value 1. What if I was to change it to printing out 2 and 3? What do we think the output for that would be? Okay, so I'm seeing 2, and that's correct. So as you can see here, that is the associated value. 2, 2, 3, using our colon, you can see here, that's how we get that association. So great job. That was sort of testing, your understanding of dictionaries where we have those key and value pairs. All right, this one is a little bit longer. We're going to be working with sets here. So say we declare a set like so. So we have our set called mySet, and we're assigning it these 5 values, 1, 2, 3, 4, 5, 6. And now let's just print it out just to make sure that's what our set looks like. And so now we want to remove some elements. So what will be the output of both of these? What will the output of both of these code snippets be? So we have the first one here. So we have our same mySet being declared. We're going to first do mySet.remove 6 and then print it out to see what is the value updated to be. The second one is mySet.remove 2, and then again printing it out to see what's the updated value of mySet. So let's have everyone guess what will be the output of the first code snippet. So mySet.remove 6. Let's see what people can guess. So I see a couple guesses in there. Any more guesses? So I see 1, 3, 4, 5, and I see 1, 2, 4, 5. Any more guesses? Okay, I see 1, 3, 4, 5. So the two different answers I'm seeing are 1, 3, 4, 5 and 1, 2, 4, 5. Okay, I'm seeing 1, 3, 4, 5 now a bit more. Okay, so I'm gonna run this, and we get 1, 3, 4, 5. And so the reason why why we get this for printing out mySet is because all it's doing is going in here, looking for our value 6, removing it, updating it, and then printing it out. So now we only have 4 elements, 1, 3, 4, 5. And so now we're using the same exact set operation dot remove, but here it's going to be a slightly different value, which is going to be the value 2. So what is everyone's guess for what will happen here when we try to remove the value 2? Okay, I see error. I see 1, 3, 4, 5, 6, nothing changes. One, 3, 4, 5, 6. Yeah, so we're getting slightly different guesses for all of these. I'll have everyone put in a few more guesses. Error 1, 3, 4, 5. Okay, so I'm going to run this and let's see what the answer is. So we do indeed get an error. So it's not going to ignore it. It's going to give you an error. And here you can see it says key error 2. And so this key error is basically telling you that there's no value 2 inside this set. So it's actually not going to let you remove it if it doesn't actually exist in there. So Unfortunately, it doesn't just ignore it, even if it's not part of the set. So you do get an error. If you were to add in the value to and then remove it, there would be no error. So that's why the $remove did work for this when you're trying to remove 6, because it was indeed already part of that set. And yes, Ingrid's question is, yes, that's really something really handy about Google Colab, is that when you get any sort of error, it'll actually lead you directly for searching Stack Overflow. So if I were to press that, you can see that it's giving you all these different sort of questions on Stack Overflow to how to solve your problem. So I definitely use that before a lot, and that's kind of why I like Google Colab so much, because it lets you sort of navigate to Stack Overflow right away. All right, so that's all the practice questions and sort of the live coding. That's everything that I had prepared for today. Here are some references. So here are some easy level questions on LeetCode that use some of these more introductory data structures. LeetCode was a resource we referenced in the first session that's very useful for tons of interview questions. Also, companies actually pull questions from this website. And then here are just a couple more examples of different operations and what you can do with the 4 data structures that we introduced today. So list, tuples, dictionaries, and sets. Yeah, so that's it for our coding session. I'm just going to wrap it up with a couple more slides. So our next session is going to be in 2 weeks, since this is a bi-weekly series. It's going to be on March 25th, same day, same time. So it's going to be Thursday, 8 p.m. Eastern time. And so we are going to be observing the time change that's coming up. So that's just for everyone to keep in mind. But we're going to be keeping the same exact time, 8 p.m. Eastern. And we're going to be covering the next sort of set of data structures. We're going to be getting into some slightly more advanced linear data structures, including arrays and matrices. And if you have any questions, please join our Slack channel that we have dedicated towards this series. We have shared the link to joining our Slack community, as well as the study group channel that we have for this series. And that is it for today. Thank you everyone for joining in. I hope you had a wonderful learning experience from all of this. And yeah, that's it for today. Thank you so much, everyone. Have a wonderful rest of your day, evening, wherever you're joining in from. Thank you.